In this video, we're going to talk about redox reactions. So if we look at this reaction here, we have magnesium reacting with oxygen in the air to form magnesium oxide. So if you think back to the first semester when we talked about oxidation and reduction, we said that for any element that is by itself, it is considered neutral. So magnesium and oxygen would both have charges of 0. Now if we look at the compound magnesium oxide, we know if we look at the periodic table, oxygen has a 2 negative charge on it because it's in group 16 or 6A, and magnesium is in group 2A, so it has a 2 positive charge on it. So if we compare the reactants to the products, magnesium goes from 0 to 2 positive. So it's become positive, which means that it has lost some electrons here. So losing electrons is referred to as oxidation. And O2 goes from 0 to 2 negative. So if we go from 0 to 2 negative, that means the oxygen has gained electrons, so that is reduction. So we have oxidation and reduction occurring in the same reaction. So as we said, oxidation is loss of electrons and reduction is gain of electrons. So if you look on mnemonics, one of them you can use is oil rig, which is written here. So oil rig stands for oxidation is loss of electrons, and rig tells us that reduction is gain of electrons. So if you look on mnemonics, that's a way that you can use to help you remember that oxidation is loss of electrons and reduction is gain of electrons. So a redox reaction, we transfer electrons from one species to another. One species gets oxidized, the other gets reduced. So in our reaction here, the magnesium gets oxidized, the oxygen gets reduced. This happens in the same reaction, so this is a redox reaction. Now, oxidation number, you may hear that term sometimes. It's related to charge, but it's not necessarily the same thing. So sometimes we will use the terms oxidation number and charge interchangeably, but they're not really the same thing. The charge is what we would think of from the periodic table. The oxidation number is what we assign the element based on the compound that it's in. So elements that are on the left side of the periodic table, on the metal side, tend to be positive, and elements that are on the right side, on the non-metal side, tend to be negative. So the way that we assign oxidation numbers, an element or a molecule by itself has to have an oxidation number of 0. So if we have magnesium, which is just an atom, or O2, which is a molecule, but it's also an element because O2 is diatomic, those would have oxidation numbers of 0. So anytime you have an element by itself, whether it's an atom or a molecule, and the only time it would be a molecule is if it's a diatomic element. But whenever you have an element by itself, it has an oxidation number of 0. Atoms that are in ionic compounds have oxidation numbers that are the same as their normal charge. So for example, if we have magnesium oxide, Magnesium has a 2 positive charge, oxygen has a 2 negative. If we had sodium in a compound, it would have a positive charge. If we had, say, aluminum in a compound, it would have a 3 positive charge, and so forth. So anything in an ionic compound will have its normal charge, which will also be its oxidation number. So if you think back to the first semester, remember elements in group 1A have a 1 positive charge, elements in group 2A have a 2 positive. If we come over to the halogens, they have a 1 negative. Those in group 16 or 6A have a 2 negative, and so forth. Atoms in a polyatomic ion or covalent compound will usually have their normal charge. There are exceptions to that. So, for example, if we look at the polyatomic ions, so you can't forget those yet, or ever, they will have their normal total charge. But there are some times where things might not necessarily always have the same charge. So hydrogen, for example, if it's bound to a metal, will have a charge of -1, and it will have a charge of +1 if it's bound to a non-metal. Oxygen is always -2 unless it's part of a peroxide. So one of the most common examples of peroxides that you might actually even have in your home is hydrogen peroxide. So the hydrogen peroxide that you keep in your bathroom cabinet is usually like 3% or something like that. But it's a formula, H2O2, mixed with about 97% water. But things like Na2O2 or BaO2 are also peroxides. So, for example, we know sodium has a positive charge. So, if there's 2 of them, that's a total of 2 positive, which means that oxygen can only have a negative charge here, since there are 2 oxygens. Same thing happens with barium peroxide. There's a 2 positive charge on barium, which means that each of these oxygens must have a negative since there are 2 of them. So oxygen will be -2 unless it's part of a peroxide, then it will be -1. Halogens are usually -1 unless they're bound to oxygen. So if we have something like Cl2O7, normally chlorine would be a -1, but in this case, oxygen is 2 negatives, so that's a total of 14 negative. So each chlorine would actually have to have a 7 positive charge on it in order to make this a neutral compound. So in this case, when we have a halogen bound to oxygen, oxygen retains its normal 2 negative charge. It is the halogen that will take on a different charge. So the other thing to remember is that oxidation numbers must add up to 0 for a neutral compound or the charge on a charged species. So if it's a neutral compound, it's going to have to be 0. If it's something like, then the charge has to add up to a -1 because this compound has a -1 charge. So be careful about that. Remember that if something is charged, you have to make the charges add up to the charge on the compound. If there is no charge, then it needs to add up to 0. So let's take a look at a few examples here. We have SO4 2 negative. So that means that this compound has a 2 negative charge on it. So if we look at this, we know oxygen retains its 2 negative charge, and there's a total of 8 negatives since there's 4 oxygens. So we need this to add up to 2 negative. So we have whatever charge is going to be on sulfur plus 4 times 2 negative has to add up to 2 negative. So in other words, has to add up to 2 negative. So if we work that out algebraically, then sulfur has to have a positive 6 charge on it. So let's take a look at a neutral compound. So we have iron oxide here, and we want to figure out what the charge is on iron and oxygen. So oxygen we know is 2 negative, so that gives us a total of 6 negative. There are 2 irons, which means that each iron must have a 3 positive charge on it. When hydrogen is bound to a nonmetal, it retains its positive charge. So we have a 1 positive on hydrogen, so that's still a 4 positive. Now we want the sum of the charges to be positive, which means that nitrogen has to have a 3 negative on it. So let's look at sodium perchlorate. So we know that sodium has a positive charge, and we know that oxygen has a 2 negative charge on it. So we want to know what the charge on chlorine is. So this is a neutral compound. So if sodium is positive and oxygen is 2 negative, then chlorine has to be positive so that we have a total of 2 positive and 2 negative to make a neutral compound. Oxygen by itself, an element by itself, is always going to be neutral. If we look at sodium dichromate here, so sodium is in group 1A, so it has a 1 positive charge on it. Oxygen has a 2 negative charge because this is not a peroxide. So we have a total of 2 positive and a total of 14 negative. So if I want to make this compound neutral, I need 12 more positive, 12 more on the positive side, and I've got 2 chromiums, so 12 divided by 2 is 6, so I would have a 6 positive charge on the chromium. So if we're trying to identify whether a reaction is a redox reaction or not, for something to be a redox reaction, there has to be 2 species that have a change in oxidation number. One gets oxidized and one gets reduced. So for example, if we look at this reaction here, we have iron reacting with oxygen to form iron 3 oxide. So iron and oxygen are both neutral. Then we end up with a 2 negative charge on the oxygen and a 3 positive charge on iron. And the product side, because each oxygen is 2 negative unless it's part of a peroxide, that's a total of 6 negative. If we divide that by the 2 irons, we have 3 positive on the iron. So iron goes from 0 to positive 3. So we've lost 3 electrons. So that would be oxidation. Oxygen goes from 0 to 2 negative. So that is reduction. Now, you will sometimes see the term reducing agent and oxidizing agent. So these two, it's easy to get this confused because you're looking at one thing and it's actually doing the opposite. So reducing agent is the one that causes reduction. If it's causing something else to be reduced, it has to be the one that is being oxidized. So the reducing agent actually gets oxidized. It causes something else to be reduced. Generally, it's the metals that act as reducing agents. Not necessarily always, but in general, most of the time it will be a metal. The oxidizing agent causes something else to be oxidized, so it's actually the one being reduced. And generally that includes nonmetals. Example here, we have iron 3 oxide reacts with carbon to form iron and carbon dioxide. So iron goes from a positive 3 charge to a charge of 0, which means that it gained electrons. So if it gained electrons, it underwent reduction. So since it underwent reduction, it's the one that gets reduced. It's causing something else to be oxidized. So iron would be the oxidizing agent. Carbon, on the other hand, goes from a 0 to a positive 4. So it's lost electrons, which means that it underwent oxidation. If it underwent oxidation, it's causing something else to be reduced. In this case, it's causing the iron to be reduced. So carbon would be the reducing agent. So we will stop here and we'll pick up with some more electrochemistry in the next video.